Hi, always wanted your own supercomputer, having your own distributed cluster? In this episode, we're gonna build one. I'm Garrett, and this is Tim Attack. Hi, so today we're gonna build our little cluster. So for this cluster, I'm gonna use the Turing PI. It's a little cluster board. It can house up to 4 nodes, so 4 servers, has network, everything built in, ready to go. You just have to assemble it and you have a whole 4-node cluster. So that's what we're gonna build up today. In a previous video, I talk about more what the Turing Pi is. You can go up in the video and I will post a link to it and you can watch that one. So yes, let's run through what we're gonna build today. Let's run through all the components. So first, let's start with the nodes. So for the nodes, I have 4 Turing RK1 modules. These are single board computers. Each one is its own full server. I got 4 of the 32 gigabyte ones. They come in 8, 16, and 32 gigabytes. And each one houses 8 cores. So overall, this cluster will have 32 cores and a total of 128 gigabytes. Furthermore, about the Turing RK1 module is besides the 8 cores, it has its own GPU, its own NPU, that is a neural processing unit for accelerating AI and machine learning, that runs at 6 TOPS, which is 6 tera operations per second. To bring it even simpler, that runs 6 trillion operations per second to play with any kind of AI application you might have. Also noteworthy is the video processing on these little boards. Video encoders and decoders, hardware accelerated up to 8K video, which is pretty neat if you want to do any kind of video processing, especially in combination with AI. So these little things are extremely powerful. Of course, that generates heat. So for each module, I got a heatsink, which I'm going to show you guys later. Let's run down the storage. So for the main board, you can extend its own storage with an SD card. For that, I'm going to use a SanDisk 256 gigabyte micro SD, and I got a high speed one because we want to make sure everything runs fast. Now let's run to the main storage. Now each RK1 module comes with its own storage. It comes with a 32 gigabyte eMMC, which is used to store the OS. You can actually move that to an external drive, and for that, the board supports NVMe SSD modules. For that, I got my hands on 4 Samsung 990 Pro with heatsink. Now, the reason why I got the heatsink one, and I showed 5 because the 5th one is an external SATA 2.5-inch SATA drive, which I'm gonna attach for backup storage, etc. I will explain more when building the cluster and configuring it in future episodes. I will explain why I got the additional one. So when it comes to the storage, I advise for building a Turing Pi setup to get the one with the heatsink. SSDs in this setup would not really need it, but I recommend it because it will extend the lifespan and because the remaining modules will also generate some heat, so it can decrease lifespan. Furthermore, I opted for the Samsung 990 Pro with heatsink because of its high speed and high IOPS throughput. Now, that's something that a lot of people forget nowadays, that When it runs to servers, especially when you're going to run multiple applications on it, like a Kubernetes cluster, etc., you can actually see an increase in something called I/O wait. And I/O wait means I am waiting for I/O. I am waiting for storage, which can become a bottleneck. So getting fast SSDs for your servers is always a pro to make sure everything runs as smooth, as fast as possible. Now, before anybody starts commenting and figure out there is a discrepancy here, yes. So let's get that one out of the way. The Samsung 990 Pro are Gen 4. So that means that they are actually designed for PCI Express Lane Generation 4. So to get the full speed out of it, you would need that. However, the RK1 module only has a PCIe lane for Gen 3, which is slower. I still opted for the fast one to ensure that I have the maximum available IOPS over the Gen 3 interface to make sure that everything runs as fast as possible. We got some additional goodies like SATA free cable, some screws, and I also got some little goodies, some 3D printed guide rails. So got here a little tool. I will post the STL file so you can print your own. This little thing is very handy for installing the heatsink on the RK1. Furthermore, I have 2 baseboards printed. Now, currently, while making this video, the Turing PI has a case of their own design in pre-order. However, I could have bought any case, but before I'm going to do that, I am going to use a simple printed base. The trick, however, is I got a second one, but this one is very handy because this one has been printed in mirror. So these are not the same. The trick behind it is that allows me to safely install the NVMe without damaging the top components of the board, because the NVMe's have to be installed in the back. And you do not want to damage anything of your board. So I got a secondary base printed. I printed in reverse so all the holes line up, and I can use it to safely install the NVMe drives. Then we're coming to power. I am going to use for power the Pico controller with the external adapter I got with the Turing Pi. And this little header here allows you to install your additional power supply for your hard drives. And I'm going to use that combined for the SATA connection to the external drive, which I'm going to use for storage. So yeah, that's about it. That's what we're going to build today. A nice, fast, little supercomputer. So let's get started. So let's get started building our nice cluster board. So let's start with the real-time clock, and that requires a CR2032 battery. So this is the slot where it actually goes into. I hope I can show it nice. You also see here that metal strip, and on the top side where the metal comes out actually has 2 hooks. So that's where you have to guide it past last. So you click it in from this side and then press it down where the metal comes out. So let's get that one a little in and click. That was not something I wanted to do that way. So now you can see it's easy to damage if you want to. Thankfully it didn't damage, but you do not want to damage electronics like this. So let's get started on installing the storage NVMe drive first. And they actually have to be installed here in the back in those 4 slots. However, as you can see, If we do that wrong, we can damage the board. So for that, I have a nice little aid. This is a 3D printed bracket for normally that I have one for the permanent setup until I have a case for it. But this one has been printed in mirror, which means that the holes actually align up in mirror. And the trick behind it is that we now can attach this board upside down. So let's try it. I'm only going to use for this board because it has a little print defect, but I'm only going to use two boards, two screws just to secure it. So let's flip this upside down. And because it has been printed in mirror, all the holes align. So let's secure this with just a little force. We do not want to screw it all the way down. We don't have to. Let's see if it will go today. There it goes. We just have to secure it so we can safely install our NVMe drives without damaging the top part, which is the whole point of this little bracket. So now it is pretty good secured. It's secured on the original, but it's secured upside down. So yeah, let's get started off the NVMe drives for our OS. So funny story. I was opening my NVMe storage boxes of the NVMe drives, and I noticed one of them was not with a heatsink. While the receipt clearly said so, so I just had to run back to the store and swap it out. So yeah, now I have actually 4 NVMe Samsung 990 Pros with heatsink. So let's get started. So let's look at this. A NVMe drive with heatsink. This one at the bottom makes it a little bit thicker, which means you need a longer screw. Now, fortunately for me, I have some NVMe mounting screw kits that have longer screws to solve this problem. So if you're using NVMe's with heatsink, I highly recommend you get some longer screws because the standard that might be shipped with it might not be long enough. So let's get these installed. Don't go too tight. Make sure it is secure, but you don't have to go extremely tight. Just enough that it is being pressed down because you don't want to overstress the mount because of the additional bottom of the heatsink. Just making sure that there's not too much pressure on it. And there you have it. 4 Samsung NVMe Pros with heatsink installed. Just gonna loosen them up a little bit. I also found the reason. There's exactly a there is a pin. There is a secure pin. It's hard to see. Let me see if I can get it into scope. There's here is a that's the best part of having a mount like this. So let's see if we can find it here. That little silver pin is that's the cause why it doesn't go down all the way. So just remember, be very careful, don't slam things down, always do things very carefully. If I loosen them enough, it straightens out and it actually doesn't touch. The downside is that is metal, so we do not want to make a connection on that pin. Actually, if you loosen it enough, you can hear it going to the pin. We're just gonna make sure that the tension is enough. A little bit looser. And because it will be upside down, there will be enough force, there will be enough gravity to, with the tension of the mount, to ensure that it will not cause any issue. As you can see, this one too, it's not touching the pins yet. So we can go a little bit tighter. A little bit. I'm just checking. This one appears to make a tiny bit contact. And if you look very carefully, you can see that there should be a gap between those pins who are unfortunately wrongfully aligned. I will have to ask Turing PI if there's anything you can do about those pins. But the truth is I don't like soldering on a piece of electronics like this. So we're just gonna see. Now, next part, we're still working on the bottom. This is the micro SD slot for the BMC, for the base, the board main controller. For that, I got myself a high-speed SanDisk, 256 gigabytes. Best part is that the Turing PI supports multiple formats of this, and regarding SanDisk, everything over 32 gigabytes is by default formatted exFAT. So you only have to open it and pop it in. No need to format it actually. So in one go, logo goes up, pins down, and it slides straight in. So before we're gonna continue, we are gonna switch the board to its main holder, so we can work on the other side. It will also be the permanent holder, and it will also, because of the gravity and that there is some room between those pins, it should make sure that there's also no contact between those. So yeah, this should work out perfectly. So let's switch the boards. I will put the links to the 3D printed models in the description below. If you like this video so far, please remember to like and subscribe. That way you will really help this channel. And there we have it. Now we can work on our modules. So let's get started on that one. So the next part of our journey in building our distributed cluster, our little own supercomputer, is putting the nodes together. So I got the RK1s with heatsink, but we need to install them. And for that, I have printed this little aid. And the reason for that is the following, actually. So when we take an RK1 and we have a heatsink, I will show it in a moment, we get two patches of thermal pads. One goes on the CPU and one goes on this one here at the most right top, which is the PM, the power management chip. So both needs to be put on, and then you need to put the heatsink on it. However, the issue is that you need to make sure it aligns perfectly with the holes for the screws. So yeah, otherwise you have to take it off, you destroy your pad. So this little guide makes sure that in the first go, it goes straight perfect and you're good to go. No issues with re-putting it on to get the screws in the right holes, alignment issues, etc. So yeah, I'm going to show you how this all works. So let's get our nodes ready for AK132, our heatsink alignment tool, and let's unwrap. They come in the little boxes I showed in the beginning of the video. So here we have the heatsink. It comes with its own cable. It plugs straight into the main board. We got 4 screws and here the two thermal pads. So this tiny one, they're double-sided, so you have to take off the tape, put it on, both on, and then alignment. Now the trick with the heatsink is you have this heatsink, those two have to go at the top. This longer than this one here at the top, which means this is the bottom. Okay, and the bottom is of course the one with the gold connectors. Now, because we need to screw into the heatsink to secure the module, we're gonna do it upside down. So this little weight actually is also perfectly aligned so that it actually can go over the heatsink. That way, there is no way for you to screw it up. It just goes perfectly over it. And then you just, because this is the top, this is the bottom, you just flip it over and it will guide it perfectly down. Thermal paste, the thermal pad will glue itself and you just screw it down. Perfect alignment, quick and easy. So let's get this show on the road. Let's see, I have the right screwdriver. Yeah, that fits. I do recommend using tweezers for this part because this is a very precise operation, because you want to do this right to make sure it conducts the heat correctly. Having an 8 like this, if you I will put a link in the description to the STL file. If you know somebody with a 3D printer, or maybe your local library has one, it should not cost you much to print, only a few cents probably. Be very careful with your tweezers because you're working near electronic connections. You don't want to damage, scrape anything. Just gently grabbing it by the corner. It should perfectly fit. Now the trick is making sure that the top plastic, let's get this in focus, that the top plastic still stays on there, because when you're satisfied that it is perfectly on the chip, you can then use your finger gently to press it down to secure it. This is always something I don't like, because you have to be very, well, I am very precise, but for some reason gluing stuff on CPUs and chips, not my favorite part. Maybe I'm too much of a perfectionist that I want to do it perfectly, but so that's one layer off. Yay! And we flip it around because we know that the long side is the bottom. And just making sure that didn't fall off. And voila. For some reason, it is all the way down, but it is not touching. Yeah, it is touching. Okay, perfect. Just the fact that it perfectly aligns is the thing that makes me just very, very happy. It is not touching, by the way. It's like the spacers are too thick. The CPU is touching, but the power module is not touching. Let's see if I can change that. No, I cannot go in there with this. This is too thick. I can. Looks like you should not be pressing it too hard. There is a tiny gap on the power module. I don't know if I can show it. There is a tiny gap between the heating pad of the power module. The CPU module is making perfect contact, the CPU and the heatsink, so that's good. I'm not sure if this will go better over time. One benefit of having a guide like this is that I can lift it straight up, so that should also mean that the CPU pad should gently come off without being ripped apart, because I don't have a replacement. That's one of the downsides. You do not get additional pads with this heatsink. You basically have one try. So this is currently very, very nerve-wracking. Let's see. Oh, it made contact here. I see a little line of glue, so it did make contact. Well, do not press on the thermal pads. Yeah, okay, so I was able to fix this by gently pulling the fur to fluff up the thermal pad again. So lesson learned, do not press on the thermal pad. Do not press on it. Just gently place it on the chip with a set of tweezers, but do not press down on it. I probably was lucky. I'm gonna leave it at least in this position. Let's hopefully that the gravity do its work, but do not press on the thermal pad, because the spacers of the heatsink are metal, unforgiving. So let's see if this worked. CPU has no gap, and there's still a gap. There is still a gap. I will have to figure out something later if I can figure out how to fluff it up while it is in this position. it does feel like that it's just not thick enough. That also might be the case. So let's see what we can do with number 2. Maybe just maybe the spacers. Well, actually, I just noticed that the thermal pad of the PM of the power management is a thicker one, so they did account for the difference. Maybe I just screwed it up too much. Let's see. Is about the same. Oh wait, I can maybe use this plastic. A trick would be not to move, not to move it, but to gently wiggle it down so it has contact at least at the corners. Also, do not touch the fan. That can cause the axle to go out of alignment and start making noise, and we want this thing to be very quiet. Hey, that's why I'm making the videos. I make the mistakes so you don't, right? If you like this, please like and subscribe. And what I learned is just shake out the thermal pads. Do not touch them. I'm not making that mistake again. Yeah, this is definitely not a job for your nails. You definitely recommend using some tweezers. Definitely use tweezers. But probably something we can fix with some plastic and gently nudging it down. I have here, oh wait, the one of the plastic of the CPU is kind of sturdy, so I'm gonna see if that is gonna work. just a little bit. So yeah, there you have it. 4 RK1 server modules ready for installment after I fix the heat pad connection. So let's continue. So, good news. Earlier in the video, I had the thermal pad of the PM, the power management chip, was not making contact with the heatsink. And it actually happened on 3 of the nodes. So in the end, I was able to fix it using a little bit of the plastic of the SanDisk packaging. So this is a little bit thicker plastic, so you can go in and actually put a little bit. So basically what I did was I went in and I started gently, like at the bottom part without moving it, which was the hardest part, very gently trying to make it contact, turning it around, at some point also going in a little bit like this, so to stretch it, so to make, and at some point it made enough contact all around, so in, up, to make sure it doesn't go off the chip, and gently trying to put it down to make enough surface contact, and that worked. So yeah, that's something you can do. So do not be too hasty in throwing out your packaging. So yeah, this little bit plastic of the SanDisk packaging was the savior of the day. So yeah, that's a little trick you can use. So now let's get started on putting it together for the final step. The final step is putting them in. So the nodes, they follow the SODIMM specification. So what we have here, this side is longer and this is shorter, which means there's only one way to putting them in. It's hard to screw up, basically impossible. And if you're able to do it wrong, you have broken your board, because it literally can go only one way. So yeah, let's put in our nodes. So just we're starting by opening all the clips. You can notice here this is the long end, this is the short end, and there's actually a divider here that has to go in there. So yeah. So I suggest you start with node 1 and then work your way. Here at the edge, it actually notes which node it is. So this is node 1. Make sure that they're fully open, and fully open means they are facing outwards. Don't push them too far. And when you click them down, it should automatically secure on the side. Now, before we're going to continue, here is actually the connector for our fan. Okay, that one is in. I think I learned from my mistake, which is connecting it first. So what you see here, you have two sides. Let's see if I can get it to focus. You have one side with the visible metal, and the other side has two notches. They're very tiny, but I think if you do the cable before, it should provide you more room. Yeah. Definitely connect it before you pop in the node. If you pop it in correctly, by the way, it should auto lock. That's the whole design of these SODIMM slots. If you pop it in correctly, it auto locks the sides. If the side does not align with the notch of the node, then it is not far enough in. So, there you have it. A assembled Turing Pi. Now what's left is fairly easy. We have our Pico module for the external power adapter and our SATA. Pop this in gently. Can only go one way, by the way, when you do it right. So there you have it, a assembled Turing Pi with 4 RK1 modules. So there you have it, a Turing Pi 2.5 with 4 RK1 modules, ready to be powered on. So if you like this video, like, subscribe, and in the next video we're gonna turn it on, start with the basic configuration and start to see if we can start flashing nodes to load our operating systems. See you guys around. I'm Garrett and this is Timmertech.